Today's topic is differentiation, and not for maths. This is the differentiation that we need to acquire the skills for physics and chemistry, basically for physics 11th and 12th. Okay, otherwise differentiation is a very vast topic, but we are interested only in 11th 12th physics. Okay, now first of all we have to know what is the meaning of this. Suppose there is a quantity that is called x or y. These are variable quantities. Okay, these are variable quantities. Now when we have any kind of change in that, changes are of two types. The first type of change is a normal change, or we can say a small change. And the second type of change is very infinitely small change. Two type of changes are there. For example, if I say that x is 1 kilometer, so there can be two type of change. One type of change can be let's say 200 meter, and the other type of change, it is suppose 0.001 millimeter. Okay, so there are two type of changes. This change is very small. This change is normal change. So when the change is normal, we use a symbol called delta. We call it delta or del or delta. Okay, but when the change is infinitely small, then we use a word small d. I am calling x as 1 kilometer. Then if the change is 200 meter, then I should write it like this: delta x equals to 200 meter. That means change. But if I am talking about this change, I should not call it delta x, I should call it dx. Okay, so first of all you have to acquire the knowledge of what do we mean by dx. Dx is not equal to d into x. Okay, dx is a complete term in itself, like dx, dy, dz. These are very small changes in x, y or z. So first of all we have to know what is the meaning of dy by dx. Okay, so when we write dy by dx, तो इसका मतलब होता है कि जो ऊपर वाला वेरिएबल है यानी कि y, तो रेट ऑफ चेंज यानी कि किस रेट से बदल रहा है कौन, जो ऊपर वाला वेरिएबल है यानी कि y, बट किसके रेस्पेक्ट में, x के रेस्पेक्ट में, यानी कि जो नीचे वाला वेरिएबल है. सिमिलरली अगर मैंने यहाँ पे लिखा होता dx by dy, इसका मतलब हो जाता रेट ऑफ चेंज ऑफ x विद रेस्पेक्ट टू y. अब हम डायरेक्टली बात करेंगे फॉर्मूलों की जो हमारे को फिजिक्स में यूज होते हैं. तो सबसे पहला फॉर्मूला नंबर 1. फर्स्ट फॉर्मूला इज डिफरेंशिएशन ऑफ एनी कांस्टेंट क्वांटिटी इज व्हाट. तो इट इज 0. Can you guess why it is 0? Because देखो dy by dx इसका मतलब क्या होता है? The meaning of this is rate of change of the upper quantity with respect to lower. लेकिन अगर कोई quantity constant है, if a quantity is constant, it means that it is not changing. Constant means it is not changing. If it is not changing, then what will be its rate of change? It will be 0. So, for example, d by dx of any number, that is 5, it is 0. d by dx of any number, suppose 1 upon pi square, it is 0. So if there is no variable, then the differentiation is 0. This is formula number 1. About formula number 2, that you have to cram right now. I will not prove it, otherwise we can prove it in maths, but it is not needed in physics. X की power n and the lower variable is also x. We are differentiating x की power n with respect to x. So the formula says power को बाहर निकाल लो, the power comes out, and then multiply it with x but decrease the power by, मैं बोलूं तो पावर बाहर और x की पावर एक कम. Take the power outside and reduce the power of x by 1. Let's see it with an example. Suppose the question is x to the power 5. So what will be its differentiation? 5 multiplied by x की power 4. ठीक है, substitute n with 5, then 5 is outside and then the power is 4. One more example of this. Let's say we have to differentiate root x. Okay, now we know that root means the power is half. So here instead of n, here it is half. So what will be its answer? Power bahar, so take half outside and then reduce the power of x by 1. Then it will become half multiplied by x to the power minus half. Okay, half minus 1 is minus half. Take the x की power minus half downwards, so the power will become plus half, and then plus half means 1 upon 2 root x. So for the students of maths, it is a standard result. They already know it. They don't have to solve it always. They cram it directly. Differentiation of root x is 1 upon 2 root x. This formula is used in physics many a times. One more example for this. Let's say we have to differentiate 1 upon x. Okay, 1 by x. So we can write 1 by x as x to the power minus 1. Okay, now instead of n we have minus 1. So how will it be differentiated? Power bahar, so take minus 1 outside, and then x, whatever the power of x, we have to minus 1 from it. So it will become minus x on x to the power minus 2. It will become minus 1 upon x square. So it is also a standard result of differentiation of 1 by x. So this is the formula that will be used in 90% or 80% cases. X to the power n, power bahar और x की power एक कम. Okay. Okay, so the formula that we have used is d by dx of x to the power n, which is n into x to the power n minus 1. Let's solve two more questions for this. Okay, now let's say the first question is 1 upon root x. Okay, now root x can be written as x to the power half. Now this formula is valid when x is in the numerator, so we will bring this x in the numerator, so the power will become minus half. Now on applying the formula, first of all take the power outside, so the power will become like this. And now the second step is to subtract 1 from the power, so this will become minus half and x to the power minus half minus 1, which means minus 3 by 2 on taking LCM. If I bring this in the denominator, the power will become plus 3 by 2. You can say that your answer is final, or we can make it look more beautiful by making it like this. Okay, how I did that? To the power 3 by 2 is x to the power 1 into x to the power half, so it is x root x. Okay, now the last question over this formula is d by dx of 1 upon x to the power 6. Let's say, so bring x in the numerator, it will become x to the power minus 6. Now minus 6 into x to the power minus 6 minus 1 will become minus 6 into x to the power minus 7. Let's bring this in the denominator, so it will become x to the power plus 7. Now this is the formula number second. Now third formula says if we are differentiating and a constant is multiplied with a function of x. Now let's understand what is the difference between function and variable. There are two quantities. First is variables, second is functions or function. Okay, variable is what? X. y, z, any quantity. Now, what is function? Anything that can be made from the variable, any combination of variable is called a function. For example, let's say milk. Okay, milk is a variable. Then what can be the function of milk? The function of milk can be curd, okay, or ghee or butter. Okay, these are the function, like sweets, like paneer. As I am a fat guy, so this is the best example that I can think of. So if a constant is being multiplied with a function, then the formula says that bring out the constant and then differentiate the function inside. This is the formula number 3rd. How it is used? It is used like this. Suppose we have to differentiate 5 into x to the power 8, right? So we can bring out 5, then we have to differentiate x to the power 8. So what will be the answer? X to the power 8, power bahar और x की power 1 कम. So it will become 40 into x to the power 7. This is the formula number 3. Okay, now let's say example number 2. Suppose we have to differentiate x to the power 3 by 2 upon 5. So 5 is also a constant. So we will take the constant outside and then we will differentiate x to the power 3 by 2. The formula says bring out the power is outside, and then subtract 1 from the power. So what it will become? It will become 3 upon 10 and x to the power half. Okay, 3 by 2 minus 1, it is half. So we can write the root x upon 10. Okay, now we have talked about 3 formulas. Basically are easily proved in maths, but I'll not waste time. Sin x, cos x, tan x, secant x, cosecant of x, and cot of x. Okay, now you have to directly remember the answer. Differentiation of sin x is cos x is minus sin x, tan x is secant square x, secant x is secant x into tan x, cosecant x is minus of cosecant x is minus of cosecant x into cot x, and cot x is minus of cosecant square x. Now how you will remember this formula? You can use either of the option. Either make a short form of MCD. MCD stands for McDonald's, the restaurant, famous. So minus sign, what is C? Any trigonometric function starting with C and in differentiation. Means minus sign will come in those trigonometric function which start with C in differentiation. You can remember it like this, TCM, which means in differentiation C वालों का जो आंसर आएगा वो कैसा आता है? माइनस का. You can clearly see cos x starts with C, so it is minus. Cosecant x, cos x, that is minus sin x, cosecant x is minus cosecant x, and cot x is minus. So in differentiation, whenever a function starts with C, the answer will be of minus sign. Now we can prove all these functions in maths, but even in physics, I'll make you prove all these 4 formulas. I won't go into detail of all these. Now, what are the other formulas that you have to remember in physics? Let me write them first. First is differentiation of log of x, where the base is e. Now, its differentiation is 1 upon x. Other formula is if the base is not x, if the base is not e, then what we have to do? Then the answer will be this. I will prove it later, but you can now just remember it. What are the other formulas? The simplest formula is e to the power x. Its differentiation is e to the power x. This is the only function which does not have any effect either of differentiation or integration. E to the power x is always e to the power x. Either you integrate it or you differentiate it, it does not change. Now the general formula for e to the power x is a to the power x. Now how to solve this? A to the power x is a to the power x into log to the base e. Basically, these are the formulas that you have to remember for differentiation in physics. Apart from these formulas, I don't think that any other formula is required in physics for differentiation. Okay, basically you have to remember these formulas. Okay, now I will teach you today only 2 more things, otherwise it will become very long video. But let's say we are talking about addition or subtraction of functions in differentiation. It is very simple. How simple it is? Let's say we have to differentiate functions which have either a sign of plus or minus between them. Okay, so it is very simple. Just differentiate them individually. The sign is plus, then the sign will come as it is, like this. Now the sign is minus, and differentiate h of x. Like, for example, let's say you have a question of sin x minus cos x plus tan x minus log x. This is e. So what will be its answer? Differentiate sin x. The differentiation of sin x will be cos x. It will come minus. Now we will differentiate cos x. The differentiation of cos x is minus of sin x. Now the sign will be of plus sign. Now the differentiation of tan x, differentiation is secant square x. Now the sign will minus, so the minus sign will come and log x will become 1 by x. If functions are being multiplied in differentiation, multiplication in differentiation, it is also very easy to remember. Let's call functions u and v. Okay, in maths you will prove all these formulas, but there is no need to prove them in physics. So if we are differentiating 2 functions which are in multiplication, so what we have to do? Let's call this first. Let's call this function as second. Take the first function outside, differentiate the second function, and then use a sign of plus. And then the function which was inside, bring it outside, and the function that was outside, bring it inside. This is the formula that is used when functions are being multiplied. Let's see it through an example. Let's say we have to solve sin of x into cos of x. So how I will apply this formula? I'll take sin x outside, and then I will differentiate cos of x. Okay, then I'll use plus sign, then I will take cos x outside, and then I will differentiate sin x. Now the differentiation of cos x is minus of sin x, and then the differentiation of sin x is cos x. So it will become minus sin square x plus cos square x. Now if you have an idea of trigonometry, then this formula is of cos 2x. Otherwise you can leave it like this. It is also equally right. So until now we have checked the formula for multiplication and differentiation. Now we'll talk about division and differentiation. Now how to use division and differentiation. The basic formula says that if two functions are in division, I am representing functions by u and v. U is a function and v is also a function. Let's call them fx and gx. Now the formula says that square the denominator first. The denominator should be squared and then the denominator should be placed first, and we differentiate the numerator. The most important thing to remember is that the sign will be of minus between them, and now reverse them. The function which was inside, take it outside, and the function which was outside, take it inside. Now this is the formula in division and differentiation. Let me repeat the step. If there are two functions u and v in division, then how to differentiate them? First of all, square the denominator, then multiply the denominator first with the differentiation of the numerator, put a minus sign in between them, and then reverse the function. Means the function which was inside, take it outside, and the function which was outside, differentiate it inside. Now let's apply this formula. I already told that the differentiation of 10x is secant square x. But now let's prove it using differentiation, using this division formula. Now we can write 10x as sin x upon cos x. Okay, so here sin x is u and cos x is v. Now the formula says square the denominator first, so I'll square the denominator, that is cos. So cos square x will be in the denominator. Now the denominator should come first and I have to differentiate the numerator. The numerator is sin x. The sign will be of minus sign, and then now I'll reverse. Sin x was inside differentiation, so now it will be outside, and cos x was outside, it will be inside now. Now cos x is outside, differentiation of sin x is cos x. Minus sign, sin x. Now differentiation of cos x is minus sin x. Okay, in the denominator it is cos square. So we are left with cos x into cos x, it is cos square x. Minus into minus is plus, sin x into sin x is sin square x upon cos square x. Now we all know that sin square x plus cos square x is equal to 1. It is an identity. It is 1 upon cos square x, and 1 upon cos square x is secant square x. Okay, so we have proved formula for differentiation of 10. Now let's solve one more example. Okay, let's solve for secant x. Now we can write secant x as 1 upon cos x. Now the numerator is 1 and the denominator is cos x. So now first of all I'll square the denominator, then I'll put denominator first, then I will differentiate the numerator, which is 1, second will be of minus, then I'll put 1 outside and I will differentiate of the denominator. Now it will result in differentiation of 1. 1 is a constant quantity and the differentiation is 0. So it will become cos x into 0 minus 1 is outside, and cos x, the differentiation of cos x is minus sin x upon cos square x. So it will become sin x upon cos square x. I can write cos square x as cos x into cos x. Now sin x on cos x is 10x, and 1 upon cos x is secant x. Okay, so the differentiation of secant x, as we already know, is secant x into 10x. So by using these formulas you can prove cot x, you can prove cosecant x. Okay, now one of the most important formula I am going to talk about. Maybe you will not use it in physics as much, but it is very important. will be used in physics, but not as frequently as some other functions. But okay, let's talk about it. If we have to differentiate any function which has the power n, previously we talked about x to the power n. The second formula which I talked about was x to the power n. Here the result was power will be outside and it will be multiplied by x to the power n minus 1. But if instead of x, if there is a function of x, then what we have to do, the same method, take the power outside, decrease the power of the function by 1 n minus 1, and now one last step is to differentiate the function without power. Just remember this thing, if by doing this, that is taking the power outside and decreasing the power of function by 1, now the role of power has ended. Now we have to differentiate the function without power. Okay, let's see it with an example. Suppose I have to differentiate secant of x. Now I can write secant x as 1 upon cos x. Okay, I can write 1 upon cos x as cos x to the power minus 1. Now the function is cos x, power is minus 1. Apply this formula. So by applying this formula, we will get power, take power outside. Now the power of cos x will be decreased by minus 1, and now I have to multiply the differentiation of cos x without any power. Okay, so now what will, okay, so once again let me revise the question. We were differentiating 1 upon cos x. Okay, so I wrote cos x, 1 upon cos x as cos x to the power minus 1. Now the formula was take the power outside, then subtract 1 power and differentiate the function without any power. Okay, now minus 1 is outside, the power of cos x will become minus 1 minus 2, and then differentiation of cos x is minus of sin x. Okay, now it will result in minus 1. Now we know cos x to the power minus 2, whenever we shift numerator into denominator, the sign of the power changes, and now here it is minus of sin x. Okay, minus minus cancels out. Now what we are left with? We are left with sin x upon cos square x. So we can write it like this, sin x upon cos x into 1 upon cos x, and we will get the same result. Sin x upon cos x is 10x and 1 upon cos x is secant x. Let me prove it. Okay, let's say we want to prove the formula for differentiation. Okay, u and v are two functions, so we can write it like this, u into v to the power minus 1. If I bring v to the numerator, its power will become minus 1. Now I'll use the formula of multiplication. I'll take u outside, and then I will differentiate the second function plus, and then I'll take the second function outside, and then I will differentiate the first function. Now it will result in this. Again we'll apply the formula. The function is raised to the power minus 1, so take the power outside, decrease the power by 1, and then differentiate the function without the power, and then v to the power minus 1 is 1 upon v, and here it is du by dx. Okay, now u is outside, it is minus 1, v to the power minus 1 is minus 2, and then it is dv by dx, and then it is 1 by v du by dx. Okay, what will become now? Minus u. Now v to the power minus 2 is 1 upon v square. It is dv by dx. The sign is of plus 1 upon v du by dx. Now take the LCM as v square. Okay, so we are left with minus u dv by dx, and here the denominator was v, here it was v square. So to balance, I have to multiply and divide by v, so that we can get v square as denominator on both sides, and then we will get v, and here it is du by dx. And here it is dv by dx. So I'll write this term first. So it will become v dv by dx minus u dv by dx upon v square. This is the formula of division that we can prove by using the formula of multiplication.